Once they're rolling, they're rolling. So easy to push. Alright, enough from this. Boom! Guys, welcome back to the Off-Grid Garage here. Not so sunny, now it is sunny but it is cold. So welcome back to the Off-Grid Garage in sunny but cold Austria. Look at this, there's not one cloud. Okay, there is one. It wasn't there before. Oh, there are a few clouds actually. It is already late afternoon, everything is shaded. The grid charger is running, but we are not at 85%. Alright, in today's video we want to take off the Smart Shunt Powerwall from the Powerwall here and install it in this little box on the other side here. Make it ready to be connected to the circuit breaker and to the bus bars. Yeah, I probably want to start with the 95mm cabling first. Get this all done. And then in the second step we do the cabling of the circuit breakers and the battery connection boxes underneath. Yeah, I think taking this one off shouldn't be a big problem, because I can just disconnect the Anderson connector there and then we are without power. I have to turn off the MPPT though, but there's no sun coming in anymore. So that is all off. Let's measure the voltage here, 53.5 volts. And let me disconnect the Anderson. Well, we are still getting 1.8 volts declining. I think that's the MPPT now. Discharging slowly, 1.6 volts. I can handle that. Is that 17? It is. Push this little button here and take out the positive. There we go. VE direct. Phillips bit. Welcome to your new forever home. Okay, I just need to figure out how to... I probably drill all the way through into the aluminium underneath. Yeah, because just using plastic screws into this grid here, that is not enough to hold it in place. Let's go all the way through. I'll just take a self-tabbing and self-drilling screw. And this should go through the plastic into the aluminium. Oh yes, it does. Done. We've got a slight problem here with the length of this bolt holding down the ring lug. It is just too short. There's almost nothing sticking out. Look at this. So I've got some slightly longer ones. Yeah, that is much better. I can already see me drilling new holes or larger holes into this plastic box. This is not going to work. Connected the Victron bus bar back to the battery shelf here, and the solar charge controller is turned on again because we don't want to miss out on these 50, 53, 55 watts here, right? So I've got these 4 connections. That looks really funny. I've got these 4 connections now connected to the Smart Shunt. And when I put this in this case here, it looks like the holes need to be somewhere over there. So if I do it like this, it would fit. And I could still screw the Smart Shunt to the box, to the wall. Probably a bit like this. Using the step drill like a router, and then it looks like this. Well, we also have to think about the VE direct connection from the Smart Shunt back to the Raspi on the other side of the room, and because I can probably not reach this VE direct port underneath there anymore once it's screwed in, we get this done now. So, and once again I have to cut one of these VE direct cables, and then we will extend it again, because it needs to go from the Smart Shunt all the way up over there through the tray into the battery shelf top compartment and connect to the Raspberry Pi. So we use one end for the Smart Shunt and the other end goes into the Raspberry Pi. Well, it doesn't connect directly to the Raspberry Pi. It goes into the USB quad-core VE direct adapter, just in the same port where it was before. Okay, got VE direct and the positive connected, because this will be our battery voltage measurement sensor. So we need to connect this somewhere to the bus bar, to the main positive up there, as close as possible to all the batteries. And I guess we use the main bus bar as our point of truth for the battery voltage of all the connected batteries. Pretty much the same as we did over here. I also drilled a hole in the shunt box and the cable duct for the VE direct cable and the positive. I couldn't leave these holes like this, incompatible with my OCD. And I've done the same here for the duct. Put a bit of a plastic plate underneath, drilled the holes so they're lining up with the box for the smart shunt. It's all good, all fixed up. I was really considering ordering a new case. Okay, so in the next step we want to do some crimping from the negative down to the smart shunt. Now is the time where we have to figure out what kind of cable length we are using, because we are joining these two negative cables again at the smart shunt. Let me show you what I mean. Yeah guys, it's whiteboard time, finally. Alright, so we've got the battery shelf on one side and we've got this new power wall, whatever it's called, on the other side. Positive bus bar here, a positive bus bar there. Negative, negative. In between we have a 4-pole circuit breaker. So we have connected one positive, the other positive, the negative, the other negative. So that's how far we are. Now in between we've got the smart shunt and we are now joining these cables back to one point. Yeah, and from here again to the negative bus bar. The positive is going straight to the positive bus bar over here. There's no joint in between anymore. So now here comes this important piece of paper in play, because this tells me exactly how long these 4 cables are. 4.99, 4.99 to the breaker, and from the breaker to the smart shunt 0.275 both cables. So from this bus bar to this common point we've got the same cable length, and hopefully the crimps are so consistent that we have the same resistance in both cables from this bus bar to the smart shunt. And now we do the same here again. These 2 cables will have the same length coming from the shunt going to the negative bus bar, and the same for the 2 positives. They need to have the same length because, well, we are 20 mil off here, so this cable needs to be a bit longer than this one. Only 20 mil, that's not much, ask your partner. So I've put a ring lock on one of the sides of this 95mm cable and we try to feed this in now. See how far we come. Yeah, 1. This is not a one-handed job. 2. 3. Yes. Alright, this is just temporarily, so we can determine the length of this beautiful cable. Maybe I'll leave it a couple of millimeters longer. I think that's better than too short, right? Be brave, cut it here. There, exactly here. Let me double check. Alrighty. So this one is this way around and that one is the other way around. Perfect, let's crimp. Amazing. And second crimp. Wow, such a good crimp. Alright, so the smart shunt is in place, the communication cable and power cable is connected, heat shrink is in place, let's put it in. It fits 100%. It's 100% the correct length. Wow. Alright my friends, after, well, quite a while, I have managed to put these two links in, connecting the circuit breaker to the smart shunt. And I must admit, I had to redo one of the links because the first edition was just 10 millimeters too long and I couldn't fit these screws in anymore. There is basically no play to move the cables left and right. Well, I guess I've got a 95 square millimeter link cable for a future battery. I'll definitely keep it. This is a lot of money, guys. But this was also the hardest part. Everything else should be fairly easy now because you've got lots of space in the duct here to move the cables around and connect them to the bus bar. I've now installed the additional cable duct on the left and right of the bus bars, so the cables can connect to the positive and negative. Negative is coming through these holes, going down here behind these cables and feeding into the smart shunt box. I just make two cables the same length because we have some space here to move the cables around, just in case one needs to be a bit longer or shorter. I can easily bend them a little bit further down, a little bit up. It was just very, very tight here because these are straight links and there's not much space to move them around. So the only thing we need to consider is that this ring lug is upside down on this side where the shunt is. Then it goes all the way up here and this one needs to be the other way around. Oh no, it doesn't. No, it's correct. That's this one here basically. Yes, it goes upside down as well. So upside down, and Bob is your uncle. Also 8mm ring lug, 10mm ring lug, very important. That is so amazing. Tell you what, if you work with 95mm cable, you don't need to work out anymore. It is not easy. Especially not when we have only 15 degrees inside here. Cable is nice cold and stiff. That's the first positive. And the ring lug needs to stay in this position. Not a problem. Okay, so this is the longer one. This is positive number 2. Positive number 1 needs to be 20mm shorter than this one. Shouldn't be a problem because this is closer to here anyway. 20mm shorter. Alright, last time cutting 95mm cable. Hopefully. This is all spare. That is a fortune. And this will be our last 95mm crimp for a while, hopefully. Game changer. Got it. Can't believe we are done with the 95mm. Wow, that is good progress. This is a bit of a Gewürje here, but this was expected because the runs are short and the space is very tight. But it is done now. The 35mm will be so much easier. I'm really looking forward to it. 4.87 plus 1.66 is the same as 4.85 plus 168. 20mm more on this side, 20mm more on that side. So we should be fairly equal with the length of the negative cables and the positive cables. And I'm very glad this plasterboard wall is still holding all this weight. Alright my friends, I think so far this worked out with the 95mm cable for today. Yeah, I think it worked out pretty well. Yeah, I've just started cleaning everything up here and I thought about this whole situation, installation here, and what I could have done better or differently. Well, at least these two cables coming from the smart shunt here, if I connect this cable to the bottom, yeah, this one to the bottom and this one to the top, I wouldn't have this crossing. So this is one thing. Yeah, this is a bit of an unnecessary crossing here. Not the end of the world, it's just an optical thing. Once everything is covered, you won't see it anymore, but it is there. So with a bit of better planning, I could have avoided this crossing here altogether. Yeah, as I said, this is a bit of a Gewürje, because all these cables here are crossing multiple times. It's not the best design, but there's not too much I can do about it. Because when you have a look at the smart shunt and look at the housing of it, yeah, where the PCB, the electronics sits in, yeah, this construct here is higher than the terminals of the smart shunt. That means I could not just swap this smart shunt around and then connect to the other side, and I wouldn't have this crossing here at all, because the cables would not connect pointing this way. Yeah, of course I could have mounted the smart shunt all the way up here on this side, and then have these two cables coming down in a loop, going into the smart shunt, the other two coming down, going in a loop, back to the bus bar. But then we had a lot longer cables as well. I was really trying to keep them as short as possible, because they're already long enough with all this connection stuff going on. I mean, it would have helped if this box would be sitting somewhere down here. We have longer cables again. Gives us a bit more wiggle room. And it is not as tight as we have it right now. But then again, longer cables is the sacrifice of something which you won't see anymore after the lid has been closed. Yeah, so yeah, that would be the only improvement or change I could have made, but it doesn't really improve anything apart from the optical perspective. So if we turn on the breaker now, we would have battery shelf voltage on this massive bus bar up here. But of course we are not going to do this, because we have to wire all these circuit breakers first. Even we have tested this in a past video. It is always a good idea to connect your bus bar on either side, positive here, negative across on the other side. So when you connect the battery over here, it is very close to the positive, but is very far from the negative. Yeah, if you connect it on this side, it is very close to the negative, but very far from the positive. And if you connect one in the middle, it has the same distance to the positive and negative. So all batteries have basically the same resistance when they connect to the bus bar. So this is definitely the correct way. Even if you connect both positive negative just on one side, it'll work. The batteries then closer to the positive negative connection will charge first, and the ones further away will charge last. But eventually they all come together at 55.2 volts. Alright my friends, I will leave a few links of all the tools I have used here in this video down in the video description. If you just started with your own project and have a lot of crimping to do, get one of these electric hydraulic crimpers. It is an absolute game changer. Especially with these larger diameter cables, 95, 120, 150 square millimeter. Yeah, one of these electric crimpers, definitely the way to go. Alright my friends, as always, thank you for watching. Thanks for all your amazing support here on the channel, for all your very generous donations. Welcome to all the new channel members. Thank you for all your amazing comments under the videos. So hit the like button to support this channel even further. Guys, until the next video when we do something potentially different again. Until then, you stay charged, stay safe, and thanks again for watching. See you then. Bye bye.